Okay, well, hey everybody, welcome back to this month's Tech Talk. My name is Brad, and I'm excited to walk you through model serving today. Now, this is our last Tech Talk of the calendar year, so we are collecting our thoughts and gathering some ideas. If you have any specific ideas, feedback, thoughts, please let us know, but we will let you know as soon as we kind of figure out what our agenda is moving into 2023. So moving into today's talk, the idea and the goal is really to provide a 101 level set of examples and education for model serving so that data scientists really can understand the fundamentals of this process, something that typically is pretty foreign to data scientists who kind of exclusively know that set of skills. So if you are a data scientist and feel like this and don't know how to deploy models or where to even start, or if you start looking at infrastructure and feel like you're an interstellar all of a sudden and think that it'll take you forever, hopefully this talk will provide some value and at least give you a starting point. Because frankly, model serving is not a trivial task. There are so many things that go into it. I'm not going to talk about this specific tweet thread, but I like it because it does a great job identifying all the considerations you need to make in addition to just the model itself, right? And then there's all these terms and phrases that you likely will hear. Things like API, containers, deployments, wrapping, production, mlops. Things that are typically foreign to data scientists. So as we go through this, what we'll start by doing is actually defining model serving and then break it down into a few components and go through an interactive example to help understand how this could be used in real life, cover some of the fundamentals, as I mentioned, of model serving, some of those core technologies that are required to understand and use. And then I'll walk through an actual code example that you can follow along through our GitHub site. So what is model serving? Let's define it as the process of converting a machine learning model into an API or service that can be distributed to and consumed by individuals, teams, IT systems, external software applications in a highly scalable production environment. Now, there's a lot to unpack here. Let's distill it a bit further and talk about number one, converting a machine learning model to an API. Number two, distributing to or deploying this API so that it can be made accessible to others or other systems. And then finally, scaling that API, the deployed API, on hosted infrastructure that can handle a very large scale. So as I mentioned, we're going to use an example to kind of set the stage here and walk through a model serving real life application. And to do so, we'll use our friend Logan, who happens to be a data scientist at a life sciences company. A couple years out of undergrad, not a ton of experience, but is proficient in machine learning, in Python, and scikit-learn. And importantly, Logan is located in Washington, D.C. Now, the problem is Logan's working with a team of biologists at his company who are studying different species of the iris flower and basically recording population counts. Now, they have millions and millions of sample data of these different iris flowers, and they need to look at the data and understand and kind of manually categorize which species are where so they can create these population counts. So in and of itself, that's a big problem because they need they need a way to expedite that process. The second problem for Logan is that these biologists are located all around the country, right? And so not only do they need a way to make their process and their analysis more efficient, but for Logan, while he can build a machine learning model using a common data set that we'll talk about that all data scientists are likely familiar with, he doesn't have a way to take that model from his laptop in Washington, D.C. and distribute to these biologists around the country. So we'll break this solution down into three steps in a demo. And the first step, frankly, is trivial and more or less a prerequisite for the purpose of this talk, is building the model itself. So we've got this iris data set, again, that you can actually download directly from scikit-learn. And it contains both width and length of the sepals and petals of a bunch of different flowers. And with that data, the idea is to build a model that can predict the species of the iris. So at the end of this task, we'll have a model. Again, This is more or less fundamental to data scientists, and Logan can build this no problem. But a couple considerations before we move on is that the model is written in Python and can run on a laptop locally. No problem. Now, the Python script that runs this model handles pre and post processing of the data. It's not as easy as just passing data through and getting data out. There are pre and post processing steps required on either end. There is a very specific set of Python packages, versions of those packages and dependencies that are required for this model to run. So the question becomes, how can somebody else run this model? Again, how can we take this model and make it, expose it, and make it accessible to others? So to start, we're going to wrap our model with an API and choose our framework to build the API. But before we do that, we need to understand what an API is. Now, API stands for Application Programming Interface. Think of it very simply as an interface that enables communication between two disparate applications. In other words, sending data back and forth, right? So Logan can run a Python script on his machine and send data through and receive data back all in one same place. But what if there was a software application or Tableau or business front end that needed to gather that same bit of information? Well, you need some sort of enabler or interface that allows for that communication. So put simply, that's what an API does. Passes data back and forth. So we now need to design our API architecture and determine the appropriate endpoints for our API service. What we'll do is build a REST API using the Fast API web framework. Now, Fast API is a really popular framework that allows you to build APIs in Python. A couple other frameworks you might have heard of are Flask or Django. Flask is the more recent one, and Fast API is even newer. It's got a lot of advantages over Flask, but it's much more performant. It's really easy to use so that any data scientist can kind of cross these hurdles of mlops. That begs the next question. What is REST? Well, REST is just an architecture style for designing APIs that follows the HTTP protocol. You may have also heard the term gRPC before. It's another type of API that follows a different protocol. And there's a bunch of nuances that distinguish the two. But for our purposes today, we're going to build a REST API because it's intuitive, integrates well with a lot of applications, and easy to understand, and more importantly, easy to build. And then finally, what is an endpoint? Well, think of it as one end of the communication channel that external systems will touch when interacting with your API service. And you could include however many API endpoints in your API as you'd like. So we need to consider what's the task at hand. In this case, the task is, we want to build a prediction service or an inference service so that our biologists can gain the same insights that Logan can on his computer. So we need to think about what are some relevant inputs. And once we do that, we'll develop our API and test and validate it. What we're then left with is this fast API that can send messages to our machine learning model, receive messages back from our machine learning model, and through this UV-corn server, communicate with a client application that we'll show in a second. Now, once we've built our API, so we started with our scikit-learn model, we've built an API, it's time to deploy this API. And there's a couple ways that we could do this. Some of the common options would be deploying through a virtual machine or a container. It's important to understand the difference. So virtual machines are essentially an emulated version of a physical computer, including layers from hardware all the way up through software. So it virtualizes, a physical computer. And containers are similar, but they're more lightweight. It virtualizes only the software layers in a computer, and they're very portable, immutable. There's lots of benefits there. Namely, it's very scalable, immutable, as I mentioned, consistent, efficient, and portable, as I also mentioned. So we're going to go with the container route, and we'll use Docker. Now, when you're taking an API and deploying it, there's a couple other factors that are really important to consider. Dependency management, as I mentioned, what are the different packages or requirements to run your code, run your model? Security, executing on runtime or Docker or container startup, restarts, and memory. Okay, so now at this point, what we'll do is basically package our API, which now consists of our scikit-learn model, the fast API framework, and a UV-corn server to kind of facilitate the interactions, all within a Docker container. So just to consolidate this into one easy to understand diagram, what we'll see is this right here. So you can think of it as this Docker container as a wrapper or a package that contains everything in here, and that a client application can send requests to and receive responses back. So with that, let's dive right into the demo. Let's see here. All right. Awesome. Okay. So what we see on my screen right now is this fast API is all the code that you can follow yourself, and that we'll paste in the description of the YouTube link. So this will basically walk us through everything that I just described in the PowerPoint slides. So with that, let's now open up, where's Visual Studio Code? Yep. So we'll open up Visual Studio Code where I've got this repository cloned and walk through a couple things. So the first thing is this model directory. And we've got a train.py file here, very straightforward using scikit-learn. I simplified it dramatically, right? We're loading in our iris dataset, training a support vector machine model, and testing out a couple inferences. So we'll just go in here and run this file real quick. Trains almost instantly. We see a couple example predictions. So these are the different species that this model can predict of the iris. Cool. So that's more or less trivial. Again, nothing new there. What I'll then do is open up this main.py file in our app directory. This is really where we'll leverage the fast API framework to build our API. So in this script, we'll define our model file name, and this is our model file that we finished training. We're now interested in building a prediction or an inference service. So we need our trained model asset, and then we'll build an app using the fast API module, load in our model using the pickle library, and define some labels that we'll need for post-processing. The next thing we'll do is define this class called iris species that inherits from the Pydantic base model module. Now, fast API uses a lot of Pydantic under the hood, which honestly builds automatic validation into your API. So what we can do here is say, we expect every input data object to be of type iris species. And moreover, we can define very specifically the data types of a given row of data that we receive. So then what we'll do is define a or define our endpoint. We talked about endpoints and the different endpoints that we can define. I can define multiple endpoints here, but we're going to build a very simple predict service. So our endpoint we'll call predict. And in this case, we're using the post method. It's one of the HTTP methods very commonly used. So you may hear HTTP get method, post, put, patch, delete are the most common ones. And there's a couple others that you could use. So the idea is somebody's going to eventually call this predict endpoint, and then something will happen when they do so and they pass through some data. And Fast API makes it really easy to do this. So right underneath our endpoint, we'll define a Python function, something that everybody who knows Python could do very, very easily. And this function will take in an iris object of type iris species, as I mentioned. So if any of these values right here are not floats, then Fast API will immediately throw a validation error. Super useful, a lot of utility and convenience there. And then we'll just use the scikit-learn syntax to predict return the top prediction and its corresponding confidence scores or the softmax probability using the predict proba method. And then return a dictionary that looks like this. Okay, so that's pretty simple. In just a couple lines of code, we've defined our API. Let's now test out this API. And to do so, we're going to use the UVicorn package or server. So in doing so, all I do is type this command. Basically, we're serving up this API. And what we see here is that it's accessible on at this link right here. So my localhost port 8000. Now, what we see out of the box is that nothing was found here. That's actually expected because we didn't define a root method. In other words, when you just access the API without an endpoint, what is supposed to be returned, or what's the expectation? And again, we didn't define one, so this is fine. We don't need one for the sake of this this demo. What I can then do is go to the docs site. Another really great thing about Fast API is they expose these automatically generated open API docs by Swagger. So this is a Swagger UI. If you ever hear of it, it's a very common framework and tool for documenting APIs. Moreover, we see this predict endpoint that uses the post method that we defined. And as I go in here, there's a lot of things that we could do, but basically it provides some validation error messaging, the media type that's expected for the request, some of the schemas. Let's go ahead and just try this out though. And what I can do is modify these values for the sepal and petal lengths and widths and execute this. Now, as I go down, we see the curl request that I could use and paste in a terminal in some application that can run a REST HTTP call. The request URL hits our API where it's being served, and then specifically the endpoint. And then we see the top prediction as a versicolor iris with this corresponding confidence score. So very easy. And what I just did was successfully test and validate that my API works. Now, what if I were to put in like a string here? Again, I talked about some of that validation that's automatically built in. And what we see is the value is not a valid float. So again, super useful. And all I had to do was define this object. And if I were to go back to my terminal here, we get some of the corresponding messages. So we have a successful 200 message returned for the predict method, and then the second one is this processable entity. So in just a couple lines of code and really a couple minutes, we built an API and spun it up and tested it. Now, if you remember in the PowerPoint, we need to take this one step further and basically deploy this API. And the way we'll do that is build a Docker container around it. So if you click on the Docker file in this repo, I'll just go through this quickly. In this Docker file, we'll start from a Python base image, make a directory that we'll call code, copy the requirements file. So these are all the Python packages needed to run this code, not very many. So we'll copy that into our container, pip install them, and then anytime the model runs or the container gets spun up, this command, this executable command will be executed. And so again, it's that same uvicorn command that we used a second ago. So there will be a uvicorn server inside the container that will spin up our app and expose the API through port 80. So we'll see what that looks like in a second. Okay, so I'm going to simply build my Docker container. So we'll say build, and we'll call our container fast API ML model, and we'll give it a version 001. Oops. And you need to pass the location of the Docker file, so period, and should just take a second. As we see, because I ran this earlier, our Docker image is now here. So if I type Docker images, we see that my fast API ML model is here. That's great. Okay, finally, let's just run this. And in doing so, what we'll see, and we should see in a second, is the uvicorn server started up and is serving our API exposed through port 80. Now, because we did some port forwarding in our Docker run command, what we should be able to do is go back to this API URL and get the same response as before. Now, if I go back to my terminal, we see that this was not found. So now what we're doing is actually communicating with the same API that's running inside a Docker container. And suddenly we took this API that I could access locally on my computer and built it into a container that can be ported, transported really anywhere and used by anybody. And so this is where the deployment becomes relevant. So again, I'll just show you that we can test this out one more time, the same way we did before. And again, we see a successful response. with the corresponding logs here, right? And if I were to see that this container is running in another terminal, Docker PS, we see in fact this model is running. So really powerful, really easy, really straightforward. And again, just with a couple lines of code, we were able to build a scalable and reusable API. Now, not included really in the demo today, but I wanted to talk about this very quickly before closing, is what to do next. So we took this iterative approach and started with our scikit-learn model that any data scientist could build. We then wrapped an API using Fast API around this model, packaged it in a Docker container. And so what's next, right? There's lots of considerations you need to think about, and scale is a big one. There are a lot of, a very common, very powerful container orchestration software called Kubernetes allows you to take this one container and scale up hundreds, thousands of copies of this to then distribute to whoever you need to make available to. So in addition, you need to think about number of users, systems, models. With every model, there's a monitoring component from a machine learning standpoint, drift detection, explainability, infrastructure management and optimization, user management that comes with authentication and authorization. How are you going to handle all of that? Auditing, security, compliance. And then, databases is a big component of this as well. Now that we have a single container that will run an API and expose an API, are we going to incorporate that into a microservice architecture, software application, or monolithic architecture? It's just important to note that monolithic is a type of software built as a unified unit that all kind of operate under the same business logic, use the same resources, database, whereas microservice architectures create a series of independent software services, each of which have their own rules, business logic, databases, etc. It's great for separating complex software applications into smaller, independent services. So something to consider. We've even considered kind of making this a series where this is 101 and very, very straightforward, very much the fundamentals, but then basically pivoting and adding on to this and talking about all these additional considerations and really how you build a robust mlops platform. So with that, thanks so much for joining. Thanks so much for listening. Let us know if you have any questions, feedback. We'd love to hear from you, and we will see you in the new year.